So in this video, we are going to look at the calculation of total cholesterol, HDL, LDL, and VLDL. So a total cholesterol, to get a total cholesterol is equal to, you have to sum the concentration of HDL, LDL, and VLDL. So, and B, we also have HDL cholesterol. So LDL cholesterol can be calculated using a Friedwald formula, and this is a Friedwald formula. The Friedwald formula is equal to, or LDL is equal to concentration of cholesterol. Concentration of cholesterol minus, open bracket, you take the concentration of HDL plus the concentration of the LDL, and that will give you an estimated concentration of the total LDL. And also, in addition, there is also another formula that you can use, that is LDL is equal to total cholesterol minus, open bracket, concentration of HDL plus, open bracket, triglycerides divided by 5. And this is what we call Friedwald formula. So Friedwald formula is the formula used for calculating the total LDL. So the estimated VLDL and LDL have more error if triglycerides are above 400 milligram per deciliter. So there is more error. There is more error if the concentration of triglyceride is above 400 milligram. So it can be calculated as a result of that. Then you can now calculate it as LDL in milligram per deciliter, open bracket, so it equals to total cholesterol minus HDL minus, open bracket, 0.16 times triglycerides. And this will give you, or this will reduce the minimal error. It will reduce the error. So these are the formula that you can use in calculating LDL. So, and then the next thing is so cholesterol esters from the core of the LDL can actually become a flagule in the wall of the artery. Yes, there is cholesterol due to the LDL. So therefore, now triglycerides are a subgroup of lipid found in your blood. They store unused calories that can later be used for energy. So if you have triglycerol, it's also another class of lipids, or it's a class of lipid, or it's a subgroup of lipid that you usually stored in adipose tissue, adrenal gland, testes, ovary, for future use to generate energy, or for energy generation for future use. So then we have a good cholesterol and bad cholesterol plus triglyceride divided by 5, and that will give us the total cholesterol core. So a total cholesterol core can be HDL plus LDL plus triglycerides divided by 5. And also, if you have your lipoprotein transporters, like for example, this is a good transporter. So outer surface of the lipoproteins are usually, the outer surface proteins provide structure and control certain activities. So usually on the outer surface of the lipoproteins, there are proteins that involve in controlling a lot of activities in terms of emulsification of the lipid so that it can have access to the aqueous environment in the body. It did that. So then the next thing is the HDL cholesterol determination principle, the HDL concentration determination principle. So the principle is when serum is react with polyethylene glycol reagent, all the low and a very low density lipoproteins are precipitated. So when you have serum, then you now react it with polyethylene glycol reagents, then the polyethylene glycol reagent will now precipitate the LDL and LDL, so they will be precipitated. So the HDL fractions remain as a supernatant, and then the supernatant will remain as a solution, while the LDL and VLDL will be settled down, so they will be precipitated. So the supernatant is then used as a sample for the cholesterol acid. So we use the supernatant for the cholesterol acid. So the HDL cholesterol expected values in serum is between 33 to 75 milligram. So low values are associated with an increased risk of cardiovascular or coronary heart disease. So if the HDL cholesterol is below 33 to 75 milligram per deciliter, it means that there is a problem, because there is an increased risk of coronary heart disease. So more HDL that indicate low risk to get coronary heart disease. So that is indicated that an inverse relationship exists between serum HDL and the risk of coronary heart disease. So it means that the higher the concentration of HDL cholesterol, then the lower risk of coming up, or the lower risk of coronary heart disease. So they are inverse relationship. So the HDL concentration, when it goes high, then the risk of developing coronary heart disease will go down. So this is the concentration, so 33 to 75 milligram per deciliter. So this is how to carry out the HDL cholesterol determination. So you have cholesterol enzymatic reagent in each of the you have 3 test tubes. So the first test tube you add 1.0 mil, 1.0 mil, and 1.0 mil on all the 3 test tubes for the blank, standard, and the serum sample. So after you do that, then you add distilled water in the blank with 500 microliter. Then in the standard, then you add the standard for HDL, then which is actually 15 grams per deciliter. Then you add 50 microliter in the test tube containing 1.0 mil of the kits, that is cholesterol enzymatic reagent. And then for the serum sample, that is the test, then you add 50 microliter also of the serum sample into the test tube containing 1.0 mil of the serum sample. Then after you do that, you shake all the test tubes, incubate in water bath for 5 minutes at 37 degrees centigrade, and then you finally measure the absorbance at 610 nanometer and record your result in the below table. So after you record it, then the next thing, then you now calculate the concentration of the HDL cholesterol. So do that, then you now take the absorbance of the test, then divided by the absorbance of the standard times concentration of HDL cholesterol standard, and the concentration of the HDL cholesterol standard is 300 milligram per deciliter. So after you do that, then you now compare it with the standard value, which is 33 to 75 milligram per deciliter. Then after you do that, then the discussion. So comment on the level of the total cholesterol in sample 1 and 2 if you do the experiment, and then comment on the level of the HDL cholesterol in the serum sample. So if you do the experiment and you finish, then you now check the concentration of the concentration of sample 1 and 2 for the total cholesterol, and then for the HDL cholesterol in the serum sample. So you discuss on that. So now this is the question, and I want you to answer. What is the familial, that is LCAT deficiency? What is LCAT deficiency? And how it affects the level of cholesterol in blood. So what is the familial LPL, that is lipoprotein lipase deficiency? Then what is the meaning of LCAT? Is long-chain fatty acyl transferase. Long acyl fatty acyl transferase enzyme. So what will happen? What will be the deficiency? What will be the deficiency of these enzymes? And how does it affect the level of the cholesterol in the blood? So I want you to answer this. So these are some of the references, and of course, these PowerPoints, as you can see, is not made by me. I got it from internet. So thank you for listening. And this is the area of clinical biochemistry. So if this is the first time you are coming to my YouTube channel, subscribe and also try to join the YouTube channel as a member.